we will see few important parameters taking N-channel MOSFET into consideration. First, consider the cutoff region. We actually have no parameters in this particular region, obviously because of no current flowing within the MOSFET. Now consider the triode region. The condition for triode region is the drain to source voltage should be smaller than overdrive voltage. We have also derived the equation for current in triode region, but as we know, the drain to source voltage in the triode region is very small, so sometimes to find the approximate drain current, we can drop the term of square of drain to source voltage, which will give us the approximate drain current to be equal to process transconductance parameter into aspect ratio into overdrive voltage into drain to source voltage. Triode region is also referred as linear region, as the graph is almost linear, representing nearly constant resistance. An important parameter is drain to source resistance, which is defined as potential drop between drain to source divided by drain current. Drain to source resistance is approximately equal to 1 upon process transconductance parameter into aspect ratio into overdrive voltage. The next parameter is transconductance parameter. It is majorly used in the analysis of small signal. Transconductance is defined as differential of drain current with respect to gate to source voltage, which will give the value of transconductance to be equal to process transconductance parameter into aspect ratio into drain to source voltage. Now we consider the third region of operation, which is saturation region. The condition for saturation region is the drain to source voltage is equal to or greater than overdrive voltage. In the previous lecture only, we have derived the equation of current in the saturation region. Depending upon the situation, you should be using the current equation considering channel length modulation. We will get the same value for transconductance parameter. However, if we have to include the channel length modulation, then the expression will change slightly. However, first of all, this parameter is not used that much in electronic devices and circuits. This parameter will be used majorly in analog electronics. There, in most of the cases, you may have to ignore the channel length modulation concept, but try to remember the value of transconductance in both the cases and judge yourself whether you have to consider channel length modulation or not. In similar manner, we can also analyze p-channel MOSFET. The formula for p-channel MOSFET are written in the short notes attached in the video's description.